Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hi, my friends. Welcome back to Math Night. I am so excited to be here with you on this Wednesday night. As you know, I always look forward to these evenings with you. It is a joy of mine to hang out, solve some math problems, and help you prepare for that math test. So before I get started, I always like to do a little introduction just because it helps me get to know who's in the room. So in the comment box, let me know where you're from, what test are you prepping for, and I always like to do like a get to know you question, just because it makes it a little bit more personal and a little less like here I am sitting at this screen talking to you. So where are you from? What test are you prepping for? And would you choose barbecue chips or salt and vinegar chips? I am a salt and vinegar chip girl all day. I love salt and vinegar chips. I hate barbecue chips. And that is a kind of a house divided thing in our house because my husband loves barbecue chips and hates salt and vinegar chips. Like he cannot stand when I eat them. So where are you from? What test are you prepping for? And salt and vinegar or barbecue? Oh man, y'all are barbecue people. Come on. Hi, Naomi. Hi, Karen. Hi, Chris. Good to see y'all. Karen, you're from Orlando, Florida. So am I. I live in Central Florida, and I've been here almost my whole life. We were in North Carolina for like 5 years when I was real little, and then we came back here and never left. Chris is from Houston. I remember that. My husband's from Texas. He's from Plano, Texas. Naomi, you're a barbecue chip. Caroline, you're my girl. So far, you're the only one who likes salt and vinegar up in here. Awesome. Karen, what part of Orlando do you live in? I'm just curious now. I'm in like the northern, like Seminole County part of Orlando. So now I'm just curious because when we say Orlando, usually people don't actually mean that you live in Orlando. They usually mean they live in like some sort of that Central Florida area. East Orlando. Awesome. Fantastic. All right. Before I get started, if you have any questions, don't hesitate to drop them in the comment box. I love interacting with you in that way, and I love answering your questions. So any question you have, drop it in the comment box. And if there are any topics that I have not gone over tonight that you're like, dang, I really wish she would have gone over blank, let me know in the comments and I will add it to my next week list. Last week we didn't really have a very big list. So I will definitely add it to my next week list. And if you have a specific problem that you're struggling with, like in test prep or whatever, and you want to email that to me, I am happy to include a version of that in our prep for the upcoming weeks. So without further ado, let's go ahead. I'm going to get my next week list going. So next week, and we'll kind of look at this towards the end. But let's go ahead and look at our first problem. So this actually, I should have a star next to this. This actually was requested by somebody. I did a Venn diagram problem, I think 2 or 3 weeks ago, and someone was like, oh, could you please do another Venn diagram problem? And I said, of course. So here we are. Here's the Venn diagram problem. Now, Venn diagrams are a way to compare data, right? And so when we think about Venn diagrams, we think about data being compared. Usually, I think most of us think of Venn diagrams as a double Venn diagram, but there are such things as 3 circle Venn diagrams where you're comparing 3 different responses. So in this case, we have 3 different responses, and let's go ahead and look at the problem. A class of 100 fifth grade students were asked. Now, this says 5th grade, so this would be built for an elementary test, K through 6, but I could easily change that to a class of 7th grade students, and it could land on a middle school test or a high school test or a 7 through 12 test. So don't think that just because it says 5th grade, it's just for my elementary people. Venn diagrams are also going to be, you can compare data on the GK as well. All right. Class of 100 5th grade students were asked what different modes of transportation they have taken in the past. Their responses are displayed on the Venn diagram to the right. What does the number 26 represent in the diagram? So I'm just going to kind of process through this before I look at my answers. I'm going to look real quick. I see that I have kids who have ridden on a bus before, and I'm going to make that a little thicker. Kids who have ridden on a bus. I see there are kids who have taken an airplane. And I see that there are kids who have taken a train. And then we have this box. And then there's the number 26 outside of that Venn diagram. So does that mean those kids have never gone anywhere in their life? Not necessarily. They were asked, let's see what they were asked. They were asked what different modes of transportation they have taken in the past. But the only 3 options that are represented on this Venn diagram are bus. I apologize for the barking in the background. That's my Great Dane. Bus, airplane, and train. What other modes of transportation are there? There's a boat. There's helicopter. There's car. There's bike. There's a subway. We have all different kinds of modes of transportation that are not listed here. So the responses are displayed to the right, and it should be 100 5th grade students, which means these numbers should all add up to 100. So we know that these 26 kids have not taken a bus, an airplane, or a train because they're not included in any of those circles, but they are included in the actual data because it's included still in this box. So let's read our answer choices and start to eliminate some of the answer choices that are not correct. A, the 26 represents the number of students who have taken a bus, a train, or an airplane. B, the number of students who didn't participate. So the number 26 represents the number of students who did not participate in the survey. C, the number 26 represents the number of students who have not taken a bus, train, or airplane. Or D, the number 26 represents the number of students who have only ridden in a car. So when we think about that number, we know it's not the number of students who have taken a bus, a train, or an airplane, because the kids who have taken a bus, a train, or an airplane are included in these three circles. B, the number of students who didn't participate. Well, they're included in the data set because they're included inside that box. So it's not that they didn't participate. So now I'm down to either the number of students who have not taken a bus, train, or airplane, or the number of students who have only ridden in a car. Can we assume that they've only ridden in a car? This is going to be the most common wrong answer choice, because people are going to think car is the more common mode of transportation on the daily basis. And so surely these kids have only taken a car. They've never taken a bus, an airplane, or a train. But could they have ridden in a car and on a cruise boat? Could they have ridden in a car and on a subway? Could they have not ever ridden in a car and only taken the subway? Maybe. Wouldn't be likely, but it's a possibility. So in this situation, we want to only choose answers that are for sure. And what I know is that this number of students is the number of students who have not been on a bus, train, or airplane. Could it be the number of students who have only ridden in a car? Sure. But that wasn't a mode of transportation that was offered in our data. So we want to make sure that we are analyzing the data for what it is and not bringing in our external bias and understanding and background knowledge into the problem, right? So in this case, C is the correct answer. So when I do problems like this, to show off that this problem, this data right here, could possibly ask a lot of different questions. So it's the same data set. All of this is the same. So there's a class of 100 fifth grade students who were asked what different modes of transportation they have taken in the past. And their responses are displayed on this Venn diagram to the right. How many students, so now we're into a different question, how many students have taken more than one of the modes of transportation displayed? That's a very critical piece of this problem. Why? Because going back to that number 26, those kids could have ridden a boat and a helicopter, or a car and a bike, or a subway and a car. Those students could have ridden more than one mode of transportation, but those modes of transportation are not displayed. So what we need to recognize is that it's asking how many students have taken more than one mode of transportation that is displayed, which is the bus, the airplane, and the train. So, how do I know if they've taken more than one mode of transportation? Well, it's that overlapping part on a Venn diagram. So if I look at my bus riders, these are all my bus riders in this circle right here. Kids who have ridden a bus. But then if I look at my airplane riders, these are all the kids who have ridden an airplane and not a bus or a train. This 14 does not mean that those kids have only ever ridden an airplane to get from point A to point B. They could have ridden a bike or a car or whatever. It's just that out of these modes of transportation, it's all they've ridden on. But what do you notice? This section right here has both yellow and purple. And then I'm going to bring in the blue. That's a little too close to the purple to my liking. I'm going to do green. So all of these numbers share with another set. So 11 kids have ridden on an airplane and a train. 18 kids have ridden on a bus and a train. 9 kids have ridden on an airplane and a bus. 10 kids have ridden on a bus, an airplane, and a train. So how many students have taken more than one? All of those. 9 plus 10 plus 11 plus 18. If it said, how many have taken exactly 2 of the modes of transportation displayed, which numbers would we include? We would only include the 9, the 18, and the 11 because the 10 intersects with all 3 circles. So if it asked for exactly 2, we would only look at the 9, 18, and 11. But because it asked for 2 or more than 1, we're looking at all of them. So I'm going to use my handy dandy calculator. And I'm going to add 9 plus 10 plus 11 plus 18, which equals 48, which is D. Any questions about that? Remember, that chat box is wide open for you. Questions, drop them in the chat box. Wondering when I'm ever going to go over how to find a geometric sequence? Drop it in the chat box. Wondering if I can go over one of those barn problems from the FTCE website? Drop it in the chat box. Whatever you need, it's why we're here on Wednesdays. All right, problem number 3. How many? Now, this one is for my 6 through 12, 7 through 12 people. So if you are not 6 through 12, 7 through 12, you don't need to know this. I will get to problems that you need to know here shortly. But I always like to pull it back in for everybody. So I will relate this back for everybody. How many real solutions does the equation below have? F of x equals 2x squared minus 8x minus 15. All right. If you are a 6 through 12, 7 through 12 person, you should know the quadratic formula. The quadratic formula. Okay. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And some of you who do not know the quadratic formula are like, whoa, that's a lot of numbers or letters. Yes, it is. You're absolutely right. So when we look at this, the number one mistake that people make is that they do not label the A, B, and C correctly. We have to make sure that our quadratic equation is in standard form. Standard form is ax squared plus bx plus c, where the plus signs could be minus signs. But that ax squared has to be first. The x squared, then the x, then the constant. So this is going to be A, this is going to be B, and this is going to be C. If it was written like this, f of x equals negative 8x plus 2x squared minus 15, this would still be B, this would be A, and this would be C because it's not in standard form. Now, the quadratic formula is one of multiple ways we can find the zeros of my equation. Zeros being the x-intercepts. So this is going to create a right side up parabola. I don't know if it's going to hit there. It could hit a lot of other places. But it's going to create a right side up parabola because this right here is positive. A is positive, it faces up. A is negative, it faces down. And it has the possibility to hit the x-axis 2 times. It also has the possibility to hit the x-axis no times or 1 time. So it could hit 1, 2, or 0. How do I figure out quickly without having to factor it or do the entire quadratic formula, how to figure out how many solutions it has? Using just that piece of it. That is called the discriminant. By using the discriminant, I can figure out how many solutions this thing has. So, if the discriminant is positive, if it's greater than 0, 2 real solutions. I didn't say they were rational. There are 2 solutions. If the discriminant is less than 0, which means it's negative, 2 imaginary solutions, which means it doesn't ever cross the x-axis. It looks something like this. Why? Because I can't take the square root of a negative number. So if I get this piece to be negative, I'm not going to be able to do that. I'm going to be solving with imaginary numbers, which means my graph is going to look like this. If the discriminant equals 0, I have 1 real solution because the square root of 0 is 0. There's no positive and negative. So negative b plus 0 is whatever, and negative b minus 0 is the same thing. So I only have 1 real solution. So now let's actually solve this. Net b squared. B squared minus 4 times A times C. As you get proficient with this, you will be able to see right away, without even solving this, what it's going to give you. because I know that -8 times -8 is 64. And I know a negative times a negative is a positive. So I'm adding another number to that. It doesn't matter what it equals. I'm going to end up with a positive response, which means I'm going to have two real solutions. I'm going to say that again. I do not need to whip out my calculator and solve 4 times 2 times 15, that equals 120, and then add 64 plus 120. I don't need to do all of that. Why? Because all I'm looking for is the discriminant positive, is the discriminant negative, or is the discriminant 0? When I end up with a positive number here, and then a negative times a negative is a positive, it doesn't matter what it's going to add to. 64 plus anything else is going to land in the positives, which is how we got two real solutions. All right, let's keep going. Naomi, you would like to see me work with fractions. You've got it. Is there anything specific? Like, is it fraction word problems? Is it operations with fractions, like multiplying, distributing, dividing, adding, and subtracting with fractions? Is there anything specific, or is it just global fractions? Let me know. All right. Ooh, excuse me. Similar kind of problem to problem 3. What type of solutions does the equation below have? But you'll notice we went from no real, 1 real, 2 real, or infinitely many real, which it's not going to be infinitely many because that's not possible for a parabola. So if you know anything about parabolas and quadratics, that ain't going to be it. But we went from a very basic answer choice to a little bit more complex, to imaginary, to real rational, 1 real rational, 2 real irrational, or no solutions. This is interesting. E is already out because I can have imaginary solutions, I can have rational solutions, I can have irrational. There isn't such thing as a no solution in a situation like this. So if you have very basic knowledge about parabolas and they offer 2 imaginary solutions, then no solutions is out automatically. Let's go ahead and use that discriminant we were talking about. So the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. But let's remember that this piece is what drives how many solutions we have. So I'm going to label this A, B, C, and I didn't just willy-nilly do that. I knew that A was attached to the x squared because this is in standard form. So I have B squared -3 squared minus 4 times A. Uh-oh. What is A? Is A x squared? That doesn't make sense because I need all of it to be numbers. I don't want to include the variable when I'm doing the quadratic formula. So A is going to be the imaginary 1 that is sitting in front of the x squared. So b squared minus 4ac. Now in this case, I can't quite do what I did last time. I can immediately tell these are not going to be imaginary solutions. Why? Because a negative times a negative is a positive, and I'm going to end up with a positive plus more positive, which is going to land in the positives. So I'm not going to end up with a negative value under my square root, which means I'm going to have real solutions. But I need to solve it a little further because even though I know I'm not going to have imaginary solutions, I need to know if it's going to be rational or irrational. So -3 times -3 is 9. 4 times 1 is 4. 4 times 7 is 28. But it's going to be a positive 28 because negative times a negative is a positive. 28 plus 9 is 37. So what does that tell me? You're like, I don't know. It tells me that we have a 37. You're not wrong. It tells us that we have a 37. But what does it tell us? Let's take a look if we were to fill in this quadratic formula. Negative b. Where did I get the -3? Because b is negative. A negative times a negative is a positive. Plus or minus the square root of, wait a minute, didn't we just do all of this? So all of that equals this. It can just go under the square root, divided by 2a. So this is 3 plus or minus the square root of 37 divided by 2. What is the square root of 37? Some decimal, right? A little bit more than 6, a lot less than 7, somewhere between 6 and 7. That makes this irrational. It wasn't 0, so it wasn't one real rational solution. That would be if it was 0. If the discriminant equaled 0. So really, I was debating between 2 real and 2 irrational. And because the number that the discriminant spit out was not a perfect square, it creates 2 real irrational solutions. If that number was 36 or 49 or 100 or 81, it would create 2 real rational solutions. But because it's not, it's irrational. All right, let's go ahead and move on to number 5. An architect is planning to build a butterfly sanctuary for a local community in the shape of a hexagonal prism, where the entrance to the sanctuary will be hexagonal. Each of the sides of the hexagon are 8 feet long. If the height of the prism is 7 square roots of 3 feet, what is the volume of the butterfly sanctuary? And to be quite frank with you, I'm not entirely sure these answer choices are correct now that I look at this problem. We might be doing one of these numbers. And that's okay. In fact, we'll just do that for right now because some of you have fill in the blank tests. So let's go ahead and draw a hexagonal prism. A prism has 2 identical bases with rectangles surrounding them. So I'm going to draw a hexagon to the best of my ability. That wasn't a bad hexagon. And then I'm going to copy and repeat that. And then connect the dots. Okay, there's my hexagonal prism butterfly sanctuary. Some really awesome architect built that because that's a really odd shaped structure, right? And then this is the entrance to the sanctuary. So people walk in through the hexagon, right? And each of the sides of the hexagon are 8 feet long. And the height of the prism is 7 square roots of 3. This is not the height of the prism. And the reason that's confusing is because that's how tall the building is, right? The building is 7 square roots of 3 feet tall, but that is not the height of the prism. By definition, the height of the prism is the distance between the 2 bases. So in fact, this is 7 square roots of 3, the distance between the 2 bases. That's the height of the prism. Now, how do I find volume of a 3D prism? Volume equals area of your base times the height. GK people, this is a classic problem for GK, middle school, and high school, right? Now, how do I find the area of a hexagon? If you are dying to memorize formulas, you can go and memorize the height of a hexagon or the area of a hexagon. I don't like to memorize things that are not necessary. The area of a regular hexagon is A equals, and you'll see why I don't like to commit this to memory, 3 square roots of 3 divided by 2 apothem squared. Look like something you want to memorize? Me neither. So, and you have to have the apothem, which is that distance right there. We were not given that. So here's what I like to do with hexagons. And it should say regular hexagonal It should say regular hexagonal prism, because then we know all the sides are the same. Well, they told us all the sides are 8 feet long, so we know it's regular, which means I can actually cut this hexagon into 6 equal triangles. I know how to find the area of a triangle. So if I can use my understanding of triangles, then I can go ahead and find the area of this hexagon, right? So I know that this equals 8, as does this, as does this. All of these sides equal 8, right? I also know that I can drop a height right here and create a 90-degree angle, which then means that this is 4 and this is 4. Following? And I just realized I have not given you enough information to solve this problem, because now what I could do is use the Pythagorean theorem to solve. If I had the diagonal of the prism, if you've joined me before, you know this is an issue with my iPad. I've had the tech guys. We have no idea why my iPad does this, but I wasn't saying anything because I was like, oh my gosh, we've literally made it 39 minutes and 18 seconds without my iPad disconnecting. And then it disconnected. All right, so we would need the distance of the diagonal, or we would need the height from the ground to the ceiling. We would need something else to be able to solve this problem that we don't have. So that said, literally can't solve that problem. So what I am going to do is I'm going to star it, because it's a problem I really do want to solve with you guys. I'm going to star it. I'm going to fix it, and then we'll do it next week. Sound like a plan? Sounds like a plan, Stan. All right. It just reconnected. Share my screen. Share my... Did it already disconnect again? Lordy, this iPad. All right, share. I can't with this silly iPad. Present screen. Not understanding because my screen is literally showing the iPad. But like, now it's not showing it. So we might have to do our, up there it is. Okay. Ta-da! All right, so we are going to star this problem, for next week, and we're going to move on to this problem because problem 5, 6, and 7 are all related to that hexagon problem. So, never mind. Yeah, problem 5, 6, and 7 are all related. So we're just going to come back to problem 5, 6, and 7, and we'll go to problem 8, which is probability. All right. Jonah is performing a magic trick with a standard 52 deck of cards. He tells the first person to pick any card out of the deck. The individual draws the 5 of diamonds out of the deck and holds on to it. Jonah then asks a second person to draw a card out of the deck. What is the probability that the second person draws a diamond out of the deck? All right, listen to me, y'all. If you know that you have basic probability or complex probability, quite frankly, on your exam, you need to understand what comes in a deck of cards, because sometimes the tests assume that you know exactly what is in a deck of cards. So if you don't, you're going to have a really hard time solving this problem, even if you understand probability. So let's talk about probability first. Probability, basic probability, is my desire over my total possible outcomes. So when we look at this, we see that Jonah is performing a magic trick with 52 cards. So what is the probability out of? How many chances do I have to pull out a card? 52. There are 52 options in my deck of cards. And he tells the first person to draw a card out of the deck. So here's my deck of cards, and they pull a card out, and they draw the 5 of diamonds out of the deck. And then they hold on to it. And then Jonah looks at the next person and says, you draw a card out of the deck. How many cards are in the deck? 52. But what happened in the first part of this story? And I love to think about problems like this in the context of like a storybook, because it makes it less intimidating and less word problem-y and more like a story. We all love a good story, right? So what happened first in this story? The first person picked a card and held on to it. So how many cards is Jonah holding now? 51. So my probability is going to be out of 51, because we're looking for the probability that the second person draws a diamond out of the deck. Well, there's not 52 cards left in the deck. Now, how many diamonds, clubs, spades, and hearts are in a deck of cards? How many diamonds, hearts, spades, and clubs are in a deck? 13 of each in a standard 52 deck of cards, which equals 52 cards. Well, what happened in the story in the beginning? A diamond was drawn out of the deck, and that person was holding on to it. So even though we got this part, we have to make sure that now instead of 13 diamonds, there are 12 diamonds, because the 5 of diamonds is in someone's pocket right now. So the probability that that second person is going to draw a diamond is 12 out of 51, which is D. What I don't want you to do is assume that because there's two situations, I'm automatically, where did that come from? That was weird. And I can't even erase it. Like it just showed up. All right, that was weird. What I don't want you to do is assume that because I have one person and then another person drawing a card, that I'm doing complex probability and that I'm multiplying my two probabilities. The only time we are multiplying with two probabilities is if it says, what is the probability that the first person does this and then the second person does this? Or what is the probability that a tail is flipped and then another tail? Or what is the probability that this, then that happens? But in this case, they said the first person did this. What is the probability that the second person does something else? So all we're doing is accounting for that. Now, if the first person put that 5 of diamonds back in the deck, the probability would be 13 out of 52 because the card was replaced. But in this situation, the card was not replaced. So that means we have to look at a different probability. So in this case, D is the correct answer. All right, we have another probability problem, which is why you see like the A and the B. Usually when I have a problem that I'm asking a different question, but we have the same scenario, I do an A and a B to represent that. Let's go ahead and look at part B. Jonah is still performing a magic trick with a deck of cards. And he tells the first person to pick any card out of the deck. The individual draws a card out of the deck and holds on to it. Do we know what that person picked? No. Jonah then asks a second person to draw a card out of the deck. What is the probability that both people draw a diamond out of the deck? So we have to look at them as isolated situations that we multiply together, right? So we have probability number 1 times probability number 2, okay? So probability number 1 is that they draw a diamond out of the deck. What is the probability that person number 1 draws a diamond out of the deck? Well, remember, probability is desire out of total possible. If nobody has done anything to this deck, how many cards do we have in our deck of cards? 52. How many diamonds do we have? 13. We already went over that. But then they hold on to it. So now, how many cards are in the deck? 51. How many diamonds are in the deck? Because we want both people to choose a diamond. And that first person held on to their diamond. 12. And I'm going to multiply straight across. Now, what if the first individual put the card back in the deck? Then I would be doing 13 out of 52 times 13 out of 52. Make sense? So I'm going to get my handy dandy calculator. $13 times 12, 156. Out of 52 times 51, 2,652, which is C. Now, likely your test is going to make you simplify that because 6 is an even number and 2 is an even number, those last digits are even. So that means that they can both be divided by at least 2. But in this case, I didn't simplify because I guess I was lazy when I was creating the answer choices, but likely your test is going to make you. So don't fret if you get this answer and then you don't see it over here. That doesn't mean you're wrong. It just means you didn't simplify it. Okay. All right. We have time for probably one more problem before I open it up for questions. What's the reason for multiplying? That is a great question. When we are looking at probability of 2 events happening exactly the way we want it to, we multiply those probabilities because let's think about it. What is the probability that I pull a diamond and then you go into that deck and pull a diamond also? That probability is a lot smaller than just me pulling a diamond out because we then have to take into account the probability of the other person's actions as well. So because it's asking for an if then, like what's the probability of this happening and this happening, we're looking at multiply because it's going to create a scenario that's not very likely, right? Or it could be very likely if it asked what's the probability of pulling any card other than 1. Like obviously that's a really high probability, but the probability of me doing it and then you doing it is smaller than just the probability of me doing it by myself. So that's why you multiply. But like I said, in this one, we did not multiply because there wasn't an if then or 2 scenarios. It was just a singular probability of one person taking an action. That was a really good question. All right. This problem is for my high school people, rational equations, and then we will be done. And then I will ask what you need help with. So far, I have fractions on my thing. Now, Naomi, you said you needed help with fractions. These are really fractions. You may not need to deal with fractions in this manner, but the way I solve this is going to be similar to the way you would solve a problem with fractions, right? So if I'm trying to solve this and isolate x, I need to get rid of all of these numerators and denominators. I can do that one of 2 ways. I can multiply each of these by what they're missing in the denominator, or I can multiply the entire equation by a common denominator so that they cancel out. I prefer that. All of these have a common denominator of x minus 2, x plus 2. So I'm going to multiply by x minus 2, x plus 2. By everything. When I multiply this by this item right here, the x minus 2's end up canceling out. So I'm left with x plus 2 times x plus 3 in the first scenario. When I multiply it by this item, the x minus 2's end up canceling out, and I have 5 times whatever is left over here, which is x plus 2. Minus, and then when I multiply this one, the x plus 2's end up canceling out, so I'm left with x minus 4 times what's left up here, which is x minus 2. Now, I'm going to do a whole lot of foiling and distributing. So here, I'm going to multiply by using FOIL, x squared plus 3x plus 2x plus 6 equals 5x plus 10 minus x squared minus 2x minus 4x plus 8. Now I'm going to simplify. X squared plus 5x plus 6 equals 5x plus 10. This negative goes all the way through. minus x squared. This becomes a negative 6x, and a negative 6x times a negative is a positive 6x minus 8. I'm going to add x squared to both sides. I'm going to continue up here. 2x squared plus 5x plus 6 equals 5 plus 6 is 11. 10 minus 8 is 2. And now I'm going to subtract all of that over to the other side so that I can get my quadratic. 2x squared plus, nope, minus 6x plus 4 equals 0. Divide everything by 2. X squared minus 3x plus 2 equals 0. FOIL it out. X minus 1 equals 0, x minus 2 equals 0, x equals positive 1, and x equals positive 2. And I blew through that problem because we were running out of time. If you are a high school or a middle school person and that did not make sense, comment in the comment box, and I will absolutely do another one of those next week. But for next week, what else do you want to see other than that other problem that we didn't do? I'm going to hang out for a few more minutes. I'm going to turn it over to Dr. A, and I will be watching the chat box for about 2 minutes to see what else you want help with. Otherwise, I will see you guys next week for Math Wednesday. Have a great weekend. Have a great rest of your week, and I will see you then. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.